So we're caught up in drama. Everybody's talking. We're caught up in problem.
Hello everyone, welcome to It's About Everything. In this video I am going to show you how you can make a PCB of the circuit that I have shown you in my previous video. If you haven't seen my previous video, there is a link down there in my description where you can go and see my video. Okay, so let's begin. Here you can see I have begun to pull all the components from the breadboard so that I can solder all of them in a Vero board. I have already soldered most of the components including the IC and the 5V regulator, and the 3 wires are for the infrared receiver. In order to make the connections, I have used the solder to bridge the connections among the pins, and this has reduced the messiness of the wire in the back. If you look closer, you will see tiny wire pieces are also attached along with the solder to connect the tricky places. This IC is the CD4017 IC, and this one is the 555 timer IC. As you can see, I have already finished putting the circuit together, and I have also added a transistor, which is a generic small signal NPN transistor connected with a 1 kilo ohm resistance to the third LED. The transistor is connected with a relay right next to it. The transistor is C1815Y. This is the infrared receiver, which is a TSOP1838IR receiver. This is the relay which is going to trigger the 220 volts after getting signal from the transistor. I have been testing the circuit with a TV remote to see if it's okay, but still there is a problem coming ahead which I did not know until the end of the project. I am going to use a wooden box to fix the circuit, the 12V switched mode power supply and the relay in it. Here I am using an LED driver as power supply. Later this LED driver causes a bit problem and I have to fix it by adding few components in the circuit, which I will tell you later. The wooden box is a 4" by 7" with a depth of only 1" and I think it will accommodate everything in it as it's the perfect dimension. It took me a bit of a struggle to complete this project perfectly, hot gluing every part on the box as disaster struck when I found out that the circuit works fine on battery but it does not when I power it on the 12V LED driver. I have tried that with a transformer and diode bridge with capacitors to smooth the output, but still it did not do very well. The circuit triggers on its own and the LED lights goes crazy blinking. I figured that it's the EMP interference from the high frequency oscillator in the LED driver and low frequency EMP from the transformer. So I added few more components in the circuit. You can see in the image, finally the problem is solved, but only partially, as it still does not work on the LED driver and only works on the transformer. I will tell you about the components added at the end of this video with a schematic. You can see it works fine now. Sometimes it mistriggers. That can be fine-tuned. This is the variable resistance connected between 5V to ground, with the middle pin connected to the output of 555 IC or input of 4017 IC. A 1 kilo ohm resistance is connected between the output and the input of the ICs. It's so sensitive that it triggers just by touching with a tweezer. I have also added a reverse protection diode because while testing I fried one 5V regulator before. And finally a 3.3 NF capacitor between the trigger and the ground to eliminate any mistrigger. The transistor that triggers the relay is here. Finally, all the components are inserted inside the box, and as I'm not going to use the LED driver, I'm going to use a transformer, and unfortunately the transformer does not fit inside the box, so I had to find out a way to put it outside the box. Now as you can see, all the wires are connected, and I am closing the box. The three LEDs and the infrared sensor are going to be seen from the outside, and everything else are going to be covered. Okay, I have mounted the device into the wall on a tube light, and you can see I am testing it right now. The range is fairly limited, not more than 5 to 6 meters, but it works very nicely. You can see the transformer is right above the box, and the transformer powers the internal circuitry, and the relay is connected with the tube light. Okay, here you can see the circuit schematic, the changed one with the new components that I have added. You can see the first component is the iron 4007 reverse protection diode. This diode protects the regulator from shorting out, or protects the entire circuit. The next component is the capacitor, 3.3 NF capacitor, that is connected from the output and the ground, from the output of the infrared receiver and the ground. You can see the infrared receiver's output is connected with the pin 2 of the 555 IC, and it is connected from the ground to the pin 2 of the 555 IC. What it does is it absorbs the surge or the voltage spikes and prevents from mistriggering. You can see the next component is the output of the 555 IC that goes into the input of the 4017 IC, which is pin 14. Here you can see it goes inside the pin 14, and there is a 1 kilo ohm resistance connected between pin 3 of 555 IC and pin 14 of the 4017 IC. And the variable resistance, you can see the variable resistance is connected between the ground and the plus 5 volt. It's 10 kilo ohm, and the middle pin is connected to pin 14. You can tune it back and forth to change the sensitivity of the circuit of 4017 IC so that it prevents mistriggering.